Page 214, roller coaster. In this example, focus on three different types of energy: PE, KE, and energy loss. The energy loss may be due to the air resistance or may be due to the friction between the rail and the wheel of the roller coaster. Then you can look at the PE, the GPE first. Higher position, greater PE. Lower position, GPE will be at the minimum. And also at the same time, you can see that the energy change, KE and PE. But at the same time, we have the energy loss. So you can see that all the energy loss should be increasing. Okay, because due to the path, longer path, greater energy loss. Okay, try to look at the example 8. Okay, roller coaster. The question tells you that the different position A, B, C, and D, and give you all the details. Now the question: state the energy changes in the train when it travels from A to C. Energy change. So you should emphasize different types of energy. At A, we have GPE, we also have KE. But what is the energy change from A to B, B to C, and so on? From A to B, you can see that GPE is decreasing. And how about the KE? KE will be increasing. But how about the work done against friction is also increasing? This one tells us that GPE loss for KE increase, it means that KE gain, and also work against friction, work done against friction. How about from B to C? From B to C, you can see that GPE gain, KE loss, and work done against friction is increasing. Like that. GPE converted into KE, at the same time converted into work done against friction. From BC, the highest kinetic energy converted back to GPE, and also work done against friction. Part C. Calculate the work done against friction when the train travels from A to D. Then at that time, you just only focus on the total GPE loss. Okay, and then how about the KE? You should consider it. Now look at this. We think that at position D, it means that the lowest position, we let it 0. By the conservation of energy, total kinetic energy, including KE and PE, final energy will including final KE and final PE. At the same time, during this process, we have energy loss. Energy loss should be the outcome, the result should be on the right hand side. Then list all equation out. Initial KE, initial PE, final PE, and final KE. In between, we have the work done, W. Then put everything into it, find out the calculation. This one will be the final result. Part B. We have the other solution, loss in KE, initial, final speed, and also loss in GPE, height difference. All the loss should be converting into work done against friction. So we just only add them together. This one will be the other answer. Okay, next question. Next example. Example 9. Waterfall. The question tells you that the waterfall is quite high, 250 meters, and the water will go into the pool under the cliff and stop it for 5 meters. Then look at this. Use the law of conservation of energy. Estimate the largest possible rise in temperature. This one will be the Form 3 syllabus, specific heat capacity, related to the energy change. So look at this, the answer. By conservation of energy, gain in internal energy, it means that loss in PE. Try to draw the diagram. This one will be the highest point. This one, the height difference will be 250. The water will have the highest speed here, and then the water will go into the pool for certain meter, is 5 meters. Then this water will stop here. Then this one explains it. Loss in PE, gain in internal energy. Internal energy of the water should be this part. So what should you do? You should try to find out the KE loss, because all the KE should be coming from the loss in GPE. Then look at this. Okay. All the PE 250 converted into kinetic energy, and this kinetic energy will be 0 at this position. But in your solution, very careful way, negate the KE. Initially, KE should be 0. Finally, KE is also 0. KE change will be 0. Everything should be related to the GPE only. The total height difference will be 250 plus 5. This one will be the GPE loss. To what? To the energy gain by water, MC delta T. After the calculation, you can find out this. Part B. Estimate the water resistance. Similar to this diagram, the water will have water resistance in upward direction, okay, to stop it down. Then by the conservation of energy, this one should be the work done against water resistance. This F should be the friction, S will be the displacement. This energy should be coming from the loss in GPE. It means that this, because the depth is 5 meters, unknown friction will be this F. This one will be the mass, G 9.81. This one is the total height difference. Okay, after the calculation, it will be 500 Newton. Part C. What is the actual temperature rise smaller than the value in Part A? After the calculation in Part A, the temperature rise should be 0.596 degrees Celsius. Okay, in this case, you should try to find out what happened. This one actually related to Form 3 syllabus and also Form 1 IS, energy change. Other than the heat, we also have the sound. This energy should be coming from the loss in GPE. Okay, but in the last solution, we haven't considered it. So this one explains why the temperature rise is smaller than our expectation.